Good day, everyone. My name is Owen. Today, I'm going to present about the Mosfet and the application of Mosfet in biomedical device. So first of all, what is Mosfet? Mosfet is also known as the metal oxide semiconductor field effect transistor, and it can be classified to N-channel Mosfet and P-channel Mosfet. N-channel Mosfet using the N-type semiconductor as the drain and source channel, and P-channel Mosfet using the P-type semiconductor as the drain and source channel. So there are also two modes of operation for MOSFET. First one is the enhancement mode. It is the E MOSFET normally off when the gate source voltage VGS is below the threshold voltage, while for the depletion mode, the D MOSFET is normally on, allowing the current flow when the VGS is below the threshold voltage. The diagram shown the MOSFET electronic diagram, it including the VGS gate voltage, the VDS the drain source voltage, and IDS the drain current. So why we use MOSFET is because of these three advantages. So first of all, it has high switching speed. Second, it has a low power consumption, and most importantly, it's compact and small in size. So these are the general functions of MOSFET. It can act as a signal amplifier and processor. It can be an electronic switch, and it is a voltage regulator, and also it is a high frequency it can be used in high frequency operation, which is utilized in the wireless communication and high speed data transmission system. Therefore, we can see that the MOSFET is being applied in many industries related to electronics, such as car automotive, industrial automation, telecommunication, and like audio system, charging circuit, and what we focus on today, the medical equipment and healthcare industry. So the main focus for the healthcare industry, which has used the MOSFET, is the blood glucose level monitoring device. So today we are going to discuss about how the MOSFET is being used in the blood glucose monitoring device. So the blood glucose monitoring device, there are several steps. The first step is the current production. So the blood glucose monitoring device includes a sensor strip that contains an enzyme capable of reacting with glucose in the blood sample. So when the blood comes in contact with the sensor strip, a chemical reaction occurs, and the chemical reaction equation has presented as follows, and it will generate a small electric current, which is in the form of proton of hydrogen ion. So this electric current is proportional to the concentration of glucose in the blood. So now MOSFET will play their role in transduction. So the current will be connected to the gate terminal of the E MOSFET, which act as a transducer in this case. So usually the modified MOSFET used is the EG MOSFET and ISF. So what is EG MOSFET? It's a extended gate MOSFET, and ISFET is also the ion sensitive field effect transistor. They all carry out the same function as in the blood glucose level monitoring device. So when the protons are accepted by the receptors of the EG MOSFET and ISFET, the electric potential of the gate electrode will be changed. So the changing VGS will operate the MOSFET, as the MOSFET will operate in the triode region as an amplifier. The VGS will determine the current flowing through the MOSFET channels, and VGS is proportional to current flow in the triode region. So the more the VGS increase, the more the current flows in the MOSFET. So that's carry out the amplification function of the MOSFET. Lastly, the signal conditioning and measurement process. So the amplifier current from the MOSFET will be converted into the voltage signal by the load resistor, and after that, the MOSFET will carry out some noise filtering and calibration process, and the conditioned voltage signal will be processed also using the calibration algorithms to determine the blood glucose level. So that's how the blood glucose level will be determined using the blood glucose level monitoring device. And the role of MOSFET play in the blood glucose level monitoring device will be shown in this circuit diagram. where the EG Mosfet will be used as a biosensor in a blood glucose level monitoring device. And this is the example for the ion sensitive field effect transistor, where it's sensitive to the concentration of the ion, and it will use to measure the blood glucose level. And that's all for today. Thank you.